Good morning, everyone. Thank you very much for your kind introduction. I feel it great honor to have been invited and to have this opportunity to give a talk today. So I would also congratulate the NECTEC 30th anniversary with you. I'm so delighted to celebrate this because we worked together with NECTEC for more than 15 years. So I'm happy to see my old friends again here today. So, oops, use this one, okay, and this one. All right, before getting into the detail of my topics today, but I just wanted to introduce ourselves about the AIST. So we're called National Institute of Advanced Industrial Science and Technology in Japan, so which is supported by METI, the Ministry of Economy, Trade and Industry, so which is established back in 2001. We merged 15 research institutes all together under METI. So each of the institution at that time, so we have over the 100 years in the history, but we worked all together under a single roof. So our main campus is situated in Tsukuba City, which is close to Tokyo, about 50 kilometers apart. But also we have the several the remote campus across the Japanese islands. So in addition to 2,500 researchers, we have the postdocs and technical staffs. And the researcher is around 5,000 people. They are such a kind of an organization. The total annual budget is about $1 billion US dollars, including the human resources. So as you may know, that there are two types of the research area. The one is the sort of the curiosity-driven science, but also we AIST is not just performing the curious-driven sciences, but also we are taking a look at the industrial needs, and then to understand the demand. And then we do our research to fill the gap over so-called valley of death. So our mission is to bridge the gap between the academia and the industry, and to transport or the technology transfer. There is a need of the research institute, like from the public sectors. So to achieve such missions, there are 7 departments that are situated, from the energy science, the life technologies, and the information technologies, and the material and the chemistry, the electronics, and some others. So amongst the research departments, in the IT human factors the department, we worked together with the other research department, but doing the research on the sensing the physical spaces and to deliver such a big data into the digital space. And also trying to understand what's happening in the digital space, and to actuate some sense of the physical space. So covering the sensing technologies, covering the securities and the high performance computing, and artificial intelligence, and robotics and the service technology. There's such a cycle that we were working on it. So, artificial intelligence for manufacturing. So one of the big changes enabled by the IoT or such a digital innovation, which is by combining the physical space and the cyberspace, and to produce the new social infrastructures. By using a lot of the sensors, including the smartphone and wearable device and lots of small devices, also the vehicles, even in the buildings and the infrastructure, civil infrastructure, public transportation and roads, and the public facilities. So there are so many the sensors embedded. So almost every event of our life and our social activities is acquired as in the digital data, and which is sent via internet to clouds. So the number of devices connected via such a network will be increasing from the 18 billion at this time to 50 billion in the year of 2020. So by having this and the kind of the big data, the real world will be captured more precisely and more in real-time fashion. Such in the data all sent into the cyberspace, and there will be created that sort of the digital copy of the real world. So in such a digital dual world, you can do the simulation, you can do the analysis by using the artificial intelligence, and to understand and the future of the real world much deeper. And then also you can deliver a lot of the insight, or you can calculate or some optimized solutions. So therefore, such a result, there will be the feedback to your real world through some of the daily services or information services. So such would change your life and the activities. Also, such movement will be again captured by the sensors, and then will be fed into the digital space. So such a cycle is so-called in a cyber-physical system, whatever you may say, but this CPS embedded into the everyday your life, and also the social activities, and then to create a new value, so which would never be happen before this kind of the digital world coming into the real. So in manufacturing, come on. Is it still 4? Okay, so in manufacturing industry, the cost reduction is very important, and also how to make the effective in the production. So, but the recent products needed more varieties to satisfy the customer's needs. So therefore, the optimization of production line is not simple. The monitoring the assembly machine status, and then how much unit how much it produces the number unit per minute, or how such a machine is having some feature of the production. So for the lab manager, the factory manager have to understand to gather such a monitor the data, and also they need to consider the production plans, and then to analyze what is the best the plan for make things more effectively. But the case study is getting more difficult because again the situation is not simple enough, and then you have to know the more complicated in the real world, and then you have to do the simulation or to predict about the future of such a product. And then by making a lot of more simulation would help the decision support. So the real world is so complicated. So if there is some data, or the complicated in the middle of this the chart. So, well, there are a lot of the very complicated networks, and a lot of not the simple the entities to compose the real world. So, if there is the simple cause-result relationship to understand by doing some experiments, so you may use the mathematical formula and then as a model. So by using the model, so you may understand the future of what will happen of this in the world. But the world is again very complicated. So if you understand the situation, so you have to make the more finer mesh, for example, to realize this on the world. So if you have the more finer mesh, so you need to have the more high-speed supercomputing system. So this is so-called the deductive computing path. On the other hand, so if you give up the creating such a mathematical model, so we can observe a lot of the events, and then to produce the kind of the statistical model. So by using this in the STEM model, you can give, although you don't know what's in the real structure of the real world, but you have just a computable model. So you can give some input, and to apply for this in the model, you will have some prediction. So, and then to understand, well, you may not really understand, but you may understand what will happen with this types of the input. So this is so-called inductive computing. So this approach is frequently used for all the big data the problems. Okay. So everything is computing in the virtual space. The smart something is to design the innovation in the real area of the grid or agriculture or society or etc. Which is they're trying to utilize the information technology, including the sensors and the computing and the high performance computing and the big data issues, and also the artificial intelligence type of the technology, which is using the computational models, and then where the artificial intelligence try to integrate the knowledge and the data. And then we are creating the dual world in the digital space, and trying to model the world for being computable. And then giving a lot of the use scenarios you can foresee the options of the future planning, and making the PDCA cycle. So that's what's happening for the industry space. So we have the white paper outlook of manufacturing by delivered by METI. So within this the white paper, the government compare with the situation of the manufacturing industry within Japan and the United States. So they are taking a look at this. Oops. Come on. Okay, taking a look at this. So for the lower bar, so that's circled in the red. So those folks never use the kind of the big data. So this is very impressive, and then the Japanese manufacturer would never use the data to optimize their business. So that this is a sort of the feeling very critical issues by our government. And then we wanted to utilize more data for our manufacturing. And then of course we worked together with the German folks, and then we hear the sort of a forum, and well, yeah, regarding the Industry 4.0 types of the activities. So there are a lot of the demonstrations between the German and Japan, but also there are a bunch of very interesting the demo up there. So for design and the production, the concept of the Industry 4.0 production system. So there are the horizontal lines, so you may see that there are the life cycle of the product. You may start with the production design, and then how to make it, and then how to manage such the process, and then the final stage to deliver such a product to customers. And then even at the customer, so you have to consider how to maintenance such a product. And then if you find some problems, which will be feedback into the product design again. So there is a good cycle of the product. And designing and the production, and you may optimize this in the process. And also, the vertical line, the flow, so you may receive an order from the client or customer, and then to understand when and what and how much quantity they need to have, and then which will be put into the production management. And then you have to deliver to the customer in time. So such and such, the process of the Industry 4.0, and which will be happen because everything is into the real virtual world. So here is the demo. So which is one of my friends is trying to demonstrate it here in the Thai. It looks like this movie. Oops. Could you play a movie? All right.
If the future were foreseeable, manufacturing would be simple. If experiences were shared, manufacturing would be wise. If thinking was united, manufacturing would be tough. By adding simulation, manufacturing will be smarter. The key to all of this is the virtual. Sharing wisdom and power to innovate manufacturing. Virtual. Powering everything. Hello, this is Lexer Manufacturing Global Headquarters. What? I see. There's a problem in the Brazil factory's G3 line extension lab.
You were saying emergency production is impossible because the diversified manufacturing processes of assembly robots aren't portable enough. And on top of that, no one established routes for the automated transport in the picking area. And the A1 line's transfer is malfunctioning and won't be able to operate for several days. That's quite a loss. Yes, we'll review our options and get back to you. Right. That is a factory overseas reporting problems. Naturally, they only call us when there's already a problem. Until we come up with and implement a solution, the factory sits there losing money like a leaking faucet. But what if we could anticipate the problem beforehand? What if we can prepare for the future? In other words, we can predict the future and take precautions. In manufacturing, we can predict the future through simulations to find the most efficient overall production methods. We call this concept SIM, Simulation Integrated Manufacturing. SIM doesn't stop with optimization, but comprehensively searches for hidden possibilities within the process in order to increase manufacturing value. At the heart of SIM is the production model, with every element and situation of a factory programmed into it. Linking or combining projects that were being run separately, all the way to the mass production process, consolidates the power of your manufacturing system. In tomorrow's world, improvements in productivity, quality, and delivery will continue, but creating new market value by comprehensively pursuing the strengths of manufacturing is the most important point. Furthermore, the powerful, massive, and interactive simulations made by SIM in virtual space will lead to innovation in manufacturing. What innovation in manufacturing through simulations means is that data from product or assembly line designs, transportation and manufacturing plans, and even information on factories collected by sensors are used to create your manufacturing facility in virtual space. Unforeseen problems involving designs for products, plans for new factories, changes to or expansion of assembly lines, transportation plans, and production schedules can be solved and optimized at the planning stage through simulations. Even if a problem occurs at a facility during mass production, work plans and product flow can continually be simulated and streamlined. And this is where experience in manufacturing and expertise in analysis and problem-solving methods can be integrated. By introducing this system, you can not only give new power to your manufacturing, but make it smarter as well. Through testing in virtual space and discovering the unrealized potential in your manufacturing system, new possibilities emerge. Creating new industry value, starting with manufacturing, is the goal of SIM. Now, in order to achieve SIM, we use the cloud manufacturing simulation system called GDFinity. So, imagine that your factory has been copied into this virtual space and that production has begun on a project that's assembly line hasn't been built yet. In other words, something like this. Now, if we switch this and this, what do you think? There's less distance to cover, reducing work time. Or, what if we move that processor and equipment storage over here, achieving pull production? The work in progress is reduced by this much. Oh, how about moving this entire production block over there? This is what's possible. Make your plans in the virtual factory instead of a physical one, and streamline and improve. That's GD50, the manufacturing simulator that gives power to your production.
Okay, so stop the movie. Thank you. So, I just wanted to introduce such a movie, so because they are very good example of the integrating the simulation into the manufacturing and the planning, and then also it goes not just for the within the factory, but also the country level or the regional level or the global level. And then it was trying to have some interviews with the company in Thai, but I skipped that part. So it was like the commercial movie, but the trying to demonstrate to you what's in the problem happening in the manufacturing process. And then there were just a single solution, but you may consider a lot of more the possibility of trying to solve such a problem. So the last week, so just I want to touch on basis about the artificial intelligence in the issues. So in Japan, to helping the manufacturing, so to utilize the artificial intelligence and the technology. So there is a slogan, which is the AI will change the world. So there are three research centers in the recently established in Japan, and there are the single committee of the industrial and the social the deployment of the artificial intelligence, which is trying to get the latest artificial intelligence method into the industry. So not just for the manufacturing, but also some service technology or heavy industries or some sort of the monitoring the products, etc. So there are a bunch of an opportunity for AI to work together with this. And then this is very quite simple flow which I have been explaining. And from the sensing, recognition, modeling, planning, and the acquisition, action, and then and then also there are several areas like domain knowledge, machine learning, and the simulation. Separately the research, doing the research as an artificial intelligence, and then there are the activity of these in the area is an AI for artificial intelligence. So this is very limited the application of the AI. But right now we're trying to understand what's in the real world and happening and how to manipulate the real world. So hooking up such an artificial intelligence technology within the real world is the area where the government is putting a lot of money to make things happen. And then this is for example, so you may probably know about the AlphaGo, which the software and the product to beat the world champion of the Go, the player. But for make things happen, so there are a bunch of the simulation performed in advance. So there are the big database of the games in the past. And also, so there are the complete simulation. You may have so many variety of the computers. And then they give the more information and to strengthen the power of the deep neural networks. So, which is of course the one of deep learning and the technology. But doing this, So you may understand what's in the best, the next hand to win the game. But the goal is the game of the perfect information. So but the real world is not such a perfect thing. So although you just know the very partially about the world, and then the database is not the perfect. There is a very small portion of it, and then you can do it with such a data very incomplete and then a very tiny portion of the simulation. So what we need to do with that? So there are more opportunities to utilize such a data for helping such a real business. Oops. So for the strengthen this and the core technology of artificial intelligence, so we established a National Center of Artificial Intelligence Research last year. So the center is actively engaged in close cooperation with the industry and other research institutions in Japan and worldwide. So the center promotes basic artificial intelligence technology researchers as well as application-inspired researchers. The center, of course, provides an environment in which leading the researchers of the artificial intelligence and it delivered the diverse, the related in the fields, they carry out large-scale the innovation work. So working together with the strong engineering support. So the planning team facilitate the close interaction between the academia and the industry. So my time is about up, so that I want to skip in a couple of slides, but currently the artificial intelligence research, giant IT companies are very strong because they have their own data gathered by themselves, and then they have the technology seeds, and also they have known the business model and what the customer want to do. But Japan and the Asian or other part of the world, so therefore the future of the artificial intelligence or IT business, so there is a bunch of the fragmentation by means of there are a wide variety of data owners, so there are many researchers engaged in different fields. And then also we need to have the more computational resources, and then we don't have the complete the business model. So so there is a good opportunity to perform the artificial intelligence research, and then they create the ecosystems. So that's an area why we put in push the artificial intelligence for the future of the basis, including the manufacturing. So, probably I will skip all of this, and then thank you very much. So with that, I would like to conclude my talk. So thank you for your kind attention, and thank you again for the organizers and having me this great opportunity. Thank you very much.